AI agents. Why do we need them and how to make them? Benefits, core concepts, building foundations, practical applications, case studies, and future trends. Please contact Professor Sardar Mn Islam Naz for comments and collaborations on the following email address: sardar.islam@vu.edu.au. AI agents are autonomous AI systems that perform specific tasks on behalf of users or other systems. They analyze data, make decisions, and take actions, adapting and learning in real time. Businesses use AI agents to automate workflows, improve decision-making, enhance customer experiences, and optimize various operations. Introduction. In a world increasingly shaped by intelligent technologies, AI agents stand at the heart of digital transformation. But what exactly are AI agents? Why are they important? And how can we build them? This video explores these questions with a deep dive into the technical insights and practical applications of AI agents, based on a comprehensive framework structured into different parts. First, we will explore the core concepts, agent architectures, and technologies behind intelligent agents, and then focus on real-world applications, in-depth case studies, and the future of AI agent development. Impact on industry and organizational performance. AI agents are not only a futuristic concept but also a fast-emerging reality with real-world impact. From optimizing logistics to transforming medicine and enabling AGI, these agents are set to redefine the limits of what machines can do in the service of humanity. Profitability. Faster data processing, lower error margins, and improved resource allocation boost bottom lines. Efficiency. Optimize time, energy, and capital through high-speed decision-making. Innovation. Enable creation of new products, services, and business models. Resilience. Rapid adaptive learning enhances performance in volatile environments. Strategic planning. Enhanced simulations and predictions support better long-term decisions. Why do we need AI agents? Benefits. Let's start with the most important question. Why do we need AI agents? 1. Efficiency and automation. AI agents automate both routine and complex tasks, reducing the need for human intervention and streamlining workflows in industries such as healthcare, finance, logistics, and customer support. 2. Scalability. Unlike traditional software, AI agents can scale their decision-making capabilities as they accumulate data. They adapt, learn, and improve over time, managing tasks at a scale no human team could handle. 3. Personalization. From recommendation systems to personal assistants, AI agents tailor experiences for individual users. This leads to better user satisfaction, higher engagement, and optimized services. 4. Real-time decision-making. In areas like autonomous driving, algorithmic trading, or fraud detection, AI agents can process large amounts of information and make split-second decisions with high accuracy. 5. Cost reduction. With automation and enhanced accuracy, AI agents reduce operational costs, minimize errors, and increase ROI for businesses. 6. Cross-domain integration. AI agents are capable of working across systems, departments, and domains. They serve as digital bridges that unify disparate systems into coherent, intelligent workflows. Concepts and foundations of AI agents. 1. Definition of an AI agent. An AI agent is an autonomous system that perceives its environment, reasons about it, and takes actions to achieve specific goals. It continuously interacts with its surroundings and adapts to changes over time. 2. The agent-environment interaction loop. Perception, sensing the environment. Reasoning, deciding what to do. Action, executing behaviors to alter the environment. 3. Types of AI agents. Simple reflex agents, react directly to perceptions. Model-based agents, maintain internal states to interpret environments. Goal-based agents, act to achieve specific outcomes. Utility-based agents, optimize actions for maximum utility. Learning agents, improve over time through data and experience. 4. Agent architectures. Reactive architectures, immediate response to stimuli. Deliberative architectures, reasoned planning and symbolic decision-making. Hybrid architectures, combination of reactive and deliberative for balance and flexibility. 5. Historical perspective. From early rule-based systems to modern intelligent assistants like ChatGPT and Siri, AI agents have evolved through decades of progress in computer science, cognitive psychology, and machine learning. Building AI agents. Foundational techniques. Now that we understand what AI agents are, let's talk about how to build them. 1. Programming fundamentals. To build AI agents, you'll need basic programming. Python is most common. Data structures, graphs, trees, queues. Algorithms, search, planning, learning. 2. Reactive agents. These are the simplest form. Think of a Roomba robot that moves based on sensor data. These agents use condition action rules, like if wall detected right, pointing arrow, turn right. 3. Deliberative agent. Deliberative agents plan before they act. They maintain symbolic world models and use planning algorithms like A*, strips, or gold trees to decide actions. Think of a chess AI evaluating moves ahead of time. 4. Hybrid agents. These are commonly used in real-world systems. For example, an autonomous car might react quickly to a pedestrian, reactive, but also plan a route to a destination, deliberative. 5. Environment modeling. The agent must understand its environment. Whether it's physical, a robot navigating a room, digital, a chatbot understanding text, or hybrid. The design of perception mechanisms, like computer vision and NLP, is critical. Key technologies powering AI agents. 1. Machine learning. ML allows agents to learn from experience. Supervised learning for prediction, unsupervised for pattern discovery, and reinforcement learning for decision-making under uncertainty. 2. Reinforcement learning, RL. In RL, agents learn optimal behaviors through rewards and penalties. It's used in robotics, gaming, like AlphaGo, and autonomous systems. 3. Natural language processing. NLP allows agents to understand and generate human language. Applications include chatbots, virtual assistants, and content summarization agents. 4. Computer vision enables agents to interpret visual information. Used in drones, surveillance, AR systems, and healthcare imaging. 5. Knowledge representation and reasoning used in deliberative agents. This involves logic, ontologies, and inference mechanisms to enable symbolic reasoning. Great! Here's part 2 of your YouTube video script for practical applications, case studies, and future trends. Practical applications of AI agents in industries and organizations. AI agents are not theoretical concepts anymore. They are powering innovations across industries. Let's explore their profound impact in various domains. 1. Robotics. Use case: autonomous drones, industrial automation, and robotic assistance. How AI agents help. Robots equipped with AI agents can navigate complex terrains, avoid obstacles, and perform tasks like warehouse sorting or surgical procedures. Key features: real-time decision-making, reinforcement learning, sensor integration. 2. Gaming and simulation. Use case: non-player characters, NPCs, strategic AI opponents, environment adaptation. How AI agents help. Game agents learn and evolve, providing human-like interactions and dynamic difficulty adjustments. Key features: learning behaviors, goal-oriented planning, real-time environment sensing. 3. Finance. Use case: algorithmic trading, fraud detection, customer service bots. How AI agents help. Agents analyze market data, identify trends, and execute trades autonomously. They can also monitor transactions and flag suspicious activity. Key features: predictive analytics, anomaly detection, high-frequency execution. 4. Healthcare. Use case: diagnostic assistance, patient monitoring, administrative automation. How AI agents help. Agents process clinical data, suggest diagnoses, and manage hospital logistics, improving outcomes and efficiency. Key features: NLP for reports, image processing in radiology, decision support systems. 5. Smart homes. Use case: home automation, security, energy management. How AI agents help. Agents control lighting, climate, appliances, and surveillance based on user behavior and preferences. Key features: context awareness, learning routines, voice interface integration. 6. Transportation. Use case: autonomous vehicles, logistics, traffic management. How AI agents help. Self-driving cars navigate roads, make decisions at intersections, and avoid collisions. Key features: sensor fusion, hybrid planning, real-time perception and control. Case studies of AI agent systems. Let's look at 3 in-depth case studies that bring together theory and practice. 1. Personal assistant agent. Project scope: building an AI assistant similar to Siri or Alexa. Core technologies: NLP for command parsing, intent recognition, knowledge graphs for query answering. Key agent design. Hybrid model combining reactive responses, e.g., timers, weather, with deliberative tasks, e.g., scheduling. Challenges. Maintaining context across sessions, understanding ambiguous inputs. 2. Smart home automation agent. Project scope. Designing an intelligent home controller that adapts to user patterns. Core technologies. Sensor data processing, supervised learning for behavior prediction, IoT device control protocols. Key agent design. Utility-based agent optimizing comfort, security, and energy use. Challenges. Ensuring privacy, managing conflicting user preferences. 3. Healthcare diagnostic agent. Project scope. Creating an agent to assist doctors in diagnosing based on symptoms and reports. Core technologies. Medical knowledge base, probabilistic reasoning, Bayesian networks, image recognition. Key agent design. Goal-based system that identifies likely diseases and recommends next steps. Challenges. Regulatory compliance, accuracy, and ethical implications in decision-making. Emerging trends and future direction. AI agents are not static. The field is rapidly evolving. Here are the major trends shaping the future. 1. Human-agent collaboration. AI agents are becoming teammates, not just tools. Future systems will emphasize cooperation between humans and agents in decision-making processes. 2. Emotional intelligence. Next-gen agents will sense user emotions and adapt responses, a critical feature for education, therapy, and customer service. 3. Explainable AI, XAI. Agents need to explain their decisions clearly, especially in sensitive fields like finance and medicine. This improves trust and transparency. 4. Multi-agent systems, MAS. Teams of agents will coordinate in decentralized systems, e.g., fleets of drones, autonomous delivery bots, or collaborative robots in factories. 5. Edge AI agent. With advancements in edge computing, agents can now operate offline or on device, reducing latency and increasing privacy, ideal for wearables, industrial IoT, and remote areas. Conclusion. AI agents can give your company, business, industry, or organizations enormous benefits. AI agents are at the center of a transformation, transforming how machines perceive, decide, and act in the world. Whether you're building a simple chatbot or an autonomous robot, understanding the concepts, technologies, and applications of AI agents is essential for the future of intelligent systems. From personalization to automation, from healthcare to finance, AI agents are everywhere, and learning how to design them is your gateway into the future of AI.